All right, so today I'll just be going over a pretty simple technique that can probably help you with algebra, and this is called partial fractions. All right, so I'm just gonna write this down real quick. All right, so first of all, you may be wondering, well, what is partial fractions? Well, partial fractions is kind of like a technique. It can help you like some problems that can help you make it way easier, and this can also help you with calculus. So partial fraction basically, some people may get confused with it, but it doesn't require to have like a variable x in the denominator, right? So like any fraction can be counted as a partial fraction. So I'm just gonna put here any fraction is a partial. And then if you don't know how to solve like these typical numerator over denominator problems that look confusing, you split the denominator into like two easy ones, and then you can like solve it, right? So I'll give you some examples real quick. These are like really basic examples just to like help you guys understand if you like kind of know what it is. I mean, so I'll just give you guys around 1 to 2 minutes to solve these problems here. I'll just write it on the board. All right, so here are the 3 problems that I want you guys to use partial fractions. I'll give you guys about like 1 or 2 minutes, so we'll end at 5:08, and then I'll just give you guys the answers. And if you guys still need help, I'll just probably give you guys the solutions. All right, so good luck with these 3 problems for now. All right, so that should probably give you guys somewhat of enough time to solve all these 3 problems. So like for these type of problems, of course, you don't really need to do partial fraction. Like these are just telling you what a partial fraction does, right? So you can split. So I'll just give you guys the answer. This is 1/3 plus 2/5. This is 2/5 plus 2/7. And this is 1/3 plus 2/7. All right, so yeah, these are just practice problems. Yeah, these are kind of easy problems, I guess. So let's just move on from these problems and maybe go over to some sort of like, I guess, a medium level problems. And then so basically a medium problem is like something like this. So like what happens if you have 4 over x minus 2 x minus 3, right? So for example, this problem, if you're just new to partial fractions, you may be confused on how to do this. But you see here that we have these 2 factors, right? We have x minus 2, and then we have x minus 3. So we want to split, since we'll have 2 factors here, we want to make this as 2 fractions, right? So the first fraction will have a denominator of x minus 2. And the second fraction will have a denominator of x minus 3. But right now we don't know what the numerators are, right? So we have to let these be variables, which I'm just going to say this is a and this as b, right? So now we have this, right? But you might be wondering, what does this do? Well, first of all, we can use least common denominator again. So you see here, our numerator will have a times x minus 3. And then we have plus b times x minus 2, right? And then you're wondering, well, we only have 1 equation in the numerator, but we have 2 variables, a and b, but this is actually 2 equations, right? So let's just look at this. So we have 4 is equal to this, which is ax. Let's expand it real quick. you have ax minus 3 times a plus bx minus 2b. Right, so we see here that this is, if we combine all the x's into one term and constants, we see that this is a plus b parentheses times x minus 3a minus 2b. But on the left hand side, we have 4, right? And 4, we can rewrite this as 0x plus 4. Right, so now we actually have two equations, right? The x is going to be one equation and the constants are going to be another equation, right? So we have 0 is a plus b, and then we have 4 is negative 3a minus 2b. So we see here that we have two equations and two variables, so we can solve, and we can just find that a is just negative 4 and b is 4. So this is just, so we rewrite the problem. So 4 over x minus 2 times x minus 3 is equal to negative 4 over x minus 2, 4 over x minus 3, and this is just our answer, right? And you might be wondering, well, what's the significance of this? Well, the significance is, for example, if you want to do some summation, right? So if we have summation, let's just use the same exact example, right? Where x is, let's just start with like 4 and then goes on to like 10. Like, you don't want to plug 4 all the way to 10 here. Instead, you want to simplify this to make an easier expression, which is I don't know what it was already, but it was like 4 over x minus 2 minus 4 over x minus 3, something like that, right? And then you can calculate each of these terms, and it's like basically like telescope. You can cancel a lot of stuff, and this will make your life way easier. You can solve this like these types of problems way faster, right? So that's kind of what the significance of partial fractions is. It's just to help you make these type of problems easier. All right, so now you kind of got what partial fractions is for like these medium type of problems. So I'll just give you more examples, and these problems probably require you a little bit more time. So I'll probably give you guys around 4 to 5 minutes. So you guys can work on these problems real quick. All right, so I'll give you guys 3 problems. I'll end at around 5. I'll give you guys the solutions around 5:17. So feel free to work on these 3 problems. Okay, so I hope that was enough time for you guys to solve these three problems. So before I go over the answer, I'll just go over the solutions to each of these problems because like these three problems are in increasing difficulty, kind of, I guess. So let's look at our example number 1. Okay, so we have 15x plus 19 over, I believe it was 2x plus 3. All right, so this is kind of similar to the previous one that I did, right? So it's like 4 over x minus 2 times x minus 3. Except that the numerator has an x in, right? So what do? Is we do the same exact thing. We split this into a over 2x plus 3 plus b over 3x plus 1. And we use least common denominator again. So this is a times 3x plus 1 plus b times 2x plus 3 over 2x plus 3 times 3x plus 1, right? So we see here that we have, this is, so the numerator is 3ax plus a plus 2bx plus 3b, right? And this is equal to 15x plus 19. So instead of the x being 0 in this case, we have x as 15. So we have 3a plus 2b as 15, and we have a plus 3b, which is 19. Again, you have two equations, you have two variables as well. And I'm going to save time by just giving you guys what a and b is. We have that a is 1, we have b is 6. So this is 1 over 2x plus 3 plus 6 over 3x plus 1. All right, so that was the first one. Probably many of you guys probably already got this because this is like a very similar problem. But let's look at number 2. So my second example was 17x minus 53 over x squared minus 2x minus 15. So for this problem, we have an x in the numerator, but our denominator in this case is not factored, right? So before you look at any of these problems, you have to make sure that the denominator is actually factored. And we can factor this denominator, right? This is 17x minus 53. Well, the denominator is x minus 5 times x plus 3, right? Everyone should know this. And so now we can use the same thing, right? And I'm kind of running out of time. We have 10 minutes. So this is, so basically you can write this as a over x minus 5 plus b over x plus 3. So you have these two equations where a plus b is 17, and you have 3a minus 5b is negative 53. So you can solve for a and b. So we get a is 4 and b is 13. So this is equal to 4 over x minus 5 plus 13 over x plus 3. So that is our answer for question number 2. Okay, so let's look at question number 3. So we have 1 minus 2x over 3 plus 2x minus x squared. For this problem, let's first multiply by -1 over -1. And this reason is because the numerator has a negative coefficient of x, and the denominator also has a negative coefficient of x squared, right? The highest degree are both negative. So let's multiply by -1. So this is 2x minus 1 over x squared minus 2x minus 3, right? So now this looks way easier to solve than the previous one, right? And we can factor x squared minus 2x minus 3 into x minus 3 x plus 1, and then you guys can exactly use the same method where this is equal to a over x minus 3 plus b over x plus 1. So you have that a plus b is 2, a minus 3b is -1. So we find that b is 3/4 and a is 5/4. So our answer is going to be 5 over 4 x minus 3 plus 3 over 4x. Right? So for if it gives you a fraction, you just put the numerator in the top and you put the denominator in the bottom, right? Like usual. So those are the three examples, but like those are like the medium levels, right? So what about like the hard ones? And the hard ones are just um basically, so the hard examples of is like, how do I split like x squared? I'm just going to make something up here, minus 2x plus 1 over x cubed, right? Okay, so I'm not going to solve this problem, but for like these type of questions where you have like x cubed or x fourth in the denominator, you split this by the number by the highest coefficient in the denominator. So for example, if this is x cubed, right? So you want to split this into 3 fractions and not 2, right? But since each of these have x, we can't do x, right? This does not work because overall, if you add these up, this would just give us the denominator of x. So we have to split this instead of x squared and x cubed, right? Where this is like a, this is b, this is c, right? We just call c because we have 3 fractions here. So basically, we use the least common denominator trick, and you find out this is ax squared plus bx plus c for this problem, right? So you can find a, b, c and get the partial fractions. So just to be aware, if it's a higher coefficient, maybe 3 or higher, you split into the number of fractions the highest power has. And if it's a repeating, you do the factor and then you do it squared or maybe even cubed, right? So that's just technically what I want to teach you for the hard questions. So let's just go back into the examples and then then I'll be done. So let's look at these examples. Now these would be I'll only give you 2 examples because like these are hard and I don't want to waste that much time on it. I just want to know if you can actually do this, right? So the first question is right here. Second one is here, right? So since we only have 2 problems in the 524, I'll give you guys around 4 minutes, I guess, to work on these problems, and then I'll go over the solutions. Right, so I'll go over the solutions at 528. All right, so I'll just be going over these two questions. So the first one, like I said, since you have, for the first case, you only have 3 factors, but these are all different. So what we want to do is we want to split this into 3 partial fractions. So I'm just going to put the question here. All right, so you want to split this into 3 fractions. So let this just be a over x minus 1 plus b over x minus 3 plus c over x minus 7. Right, so we used the least denominator trick. So we have that this is a, and then x minus 3 times x minus 7 is x squared minus 10x plus 21. And then plus b times x minus 1 times x minus 7 is x squared minus 8x plus 7. And then we have plus c, and then x minus 1 times x minus 3 is x squared minus 4x plus 3. Right, so we have this, and we see here that we have a plus b plus c is 2. This matches the x squared coefficient. We have negative 10a minus 8b minus 4c is negative 12. This matches the x coefficient. And then 21a plus 7b plus 3c is 10. And this matches the constant. So we have 3 equations and 3 variables, right? So we can just solve for a, b, and c. I'm just going to give you guys what a, b, and c is. A is 0, b is 1, c is 1. So this is just gives you 1 over x. This gives us 1 over x minus 3 plus 1 over x minus 7. That's our answer. So you see here that in this case, we don't have anything in the x minus 1, and that's because this numerator divides x minus 1. So basically another tip for you guys when you're counting these problems is to factor out the numerator if you can, of course, and see if it divides any of the factors in the denominator. If it does, you can partial fraction this one less fraction, right, which will help you save a lot of time. So that's a good tip. Just factor out the numerator and see if it can cancel out the denominator. But nevertheless, we still got the answer, which is 1 over x minus 3 plus 1 over x minus 7. So let's look at the second question that I gave you. And this is 5x minus 7 over x minus 1 cubed. So we have the same repeating factor 3 times, right? Because the power is 3. So we split this into a over x minus 1 plus b over x minus 1 squared plus c over x minus 1 cubed. So this is just a times x minus 1 squared plus b times x minus 1 plus c over x minus 1 cubed. So we see here that we have ax squared minus 2ax. We have plus b of x, and then we have plus a minus b plus c, and then this is equal to 5x minus 7. We see here that a is obviously 0, right? Because the right hand side has no coefficient of x squared. We have b is 5, and similarly we have that c is going to be negative 2. So our answer is going to be 5 over x minus 1 squared minus 2 over x minus 1 cubed. So for this problem, just basically wants to test you that if you know how to partial fraction a repeating factor. All right, so this is going to be the end of my lecture. I hope you guys understand more of partial fractions. All right, so Aaron, I'll hand it back over to you.